Come on. Someone besides Chloe. All right, Antonio, go ahead and do the first one. Sometimes, guys, sometimes.
Is there any way I can get moderator? Because if not, the thing starts going out really fast. The mic.
It's because Miro has good features. There you go. Sorry.
All right, so now you're good. Now I'll explain. Okay, so the amplitude's always 3, and the way you tell what the amplitude is the one outside right here. The vertical shift, that would be the -1, so I'll be down 1. Wait, no. Hold up.
You know, Bellwork, you're supposed to do this before we start class. Everyone who's in the live session right now, that's what Bellwork is. You know, you get it done. You don't do it like when we're doing it together. I may have not stated that ever this year, but being a senior level math class, I thought that it was common knowledge.
You're supposed to write this way, right? Vertical shift. Wait, no, horse. Yeah, vertical.
So I would take that, yes, but no, that's actually not correct. That would be midline. So like your assignments, your quizzes, and your tests, I think they ask for. I think they kind of flip flop back and forth between vertical shift versus midline. So what you gave me, y equals -1, that would be midline. Which on your TGA, if you did that, I gave you credit for it. All right. So Antonio, talk to me why you put +3 here and not -3.
The amplitude is never going to be negative.
Yeah, that's a good reason. Yeah, amplitude is never negative. That's very good.
And then for the horizontal shift, the reason it's positive, which is the right, because this thing lies if it's inside the equation. If you solve for it, it's not going to lie to you. But if you take it from the equation, it's just going to lie. And the only way you can take it from the equation is if the I think it's a k here. Yeah, if the k value is supposed to be right here is a 1, you can just take this number.
Right. So what's another way I could have wrote vertical shift besides writing the midline equation?
Down 1.
Yeah, I could just said down 1. Now, why wouldn't you? Hold on, I almost wrote with a real pen on my screen. That would have been bad. Why wouldn't we say down -1? Why wouldn't that be an answer?
It wouldn't make much sense.
Yeah, it's a little redundant saying down -1. It's you know, whenever you give like a shift, a direction, it's either for vertical, it's either up or down that many units, and then for phase shift, it's either left or right that many units. Shifting is never negative. That's why you tell me the direction. So I was literally having a math panic attack yesterday grading people's TGAs. That's why I'm going over this problem here, because there's nowhere in class where I ever made shifting negative. And there's nowhere that I can remember where I left out the direction. So when I graded back-to-back submissions of people putting a vertical shift of being like, let's say, -5, I was like, question mark? Why? Obviously, -5 or whatever isn't the answer, of course. I just chose some random number. But back-to-back papers I was grading, they would put the shifting as just a number, like a 5 or a -5. And I was like wondering, I was like, when I talk and I teach and I go through these lessons, and we've done many of these, I feel like, are you actually listening and taking notes and working out examples and going through the modules and doing those practices? Because the ones I graded yesterday, it made me feel like a lot of you just skipped over very basic principles of, you know, writing shifting. I'm just really confused. Either that or I started thinking, I was like, I'm getting so many duplicate wrong answers written the wrong way. Are you guys somehow searching for these questions and finding the answer that is wrong and just copying it down? It makes me wonder, but then when I search for it, I can't find it. So I don't know. I think it's very weird that it was like literally 10 submissions back to back where I kept getting the shifting as just a number and a negative number. And I started putting a little, if you open your submissions, I put little comments next to some work, whether it's like good job or not so good job, and I'll give you kind of feedback. I started just putting no. So next to like a number, I just put no. I was tired of writing out why. I just put no. And the next one, no. And that's why I'm addressing it right now. And that's why I did it, because I graded so many that were just so wrong. I was literally, I could feel my heart beating. I was like, this is not good. It really bothered me, believe it or not. So that's why I did this as a bell work. It's a good thing that you get 2 submissions for your part 2. So you can fix this. So again, to recap, shifting. It's either up, down, left, or right, that many units. I will allow you to do vertical shift as the midline equation, y equals -1 in this case. That's okay. But writing just this without the direction, that's a no-go. Now tell me, when you guys go through the quizzes and the examples, does it omit the direction as well? Because if it does, I'll take back everything I just said and give you credit for it. Okay. All right. Antonio confirms it does say the direction. Okay. So I'm just not crazy, because I feel a little crazy right now. A little math crazy. All right. The second one. The person in chat, somebody in class brought this to my attention. They are not in. Nope, they're not here, so I won't say their name. All right. So, and I know. So amplitude. Cosine, does it have an amplitude? Yes, it does. Yes, it does. So I'm gonna put my pen away from me so I don't accidentally write on my screen. Yes, cosine has an amplitude. All right. Does sine have an amplitude? Yep, sure does. Yep. Does tangent? Yep, no, it does not. Even though it has the A here, this does not act like an amplitude. The A just makes it either steeper or flatter when you graph it. So yeah, if I ask for amplitude, you just say none, right? So there's no amplitude for tan. Secant, does it have an amplitude? No, it does not actually. So in fact, all of these do not have an amplitude. So, and I'm pretty sure I misspoke multiple times when I talked about amplitude, and I said tangent, cotangent don't have amplitudes, which is true, but I did say probably once or twice, probably more than that cosecant and secant have amplitudes, and they actually don't. And somebody emailed me, snipped one of my lessons that I actually had it written down. So at one time I did say it right, but I think after that point I just totally just said it wrong. So to make it clear, so all of you are now aware, only cosine and sine actually have amplitudes. The rest of them, they don't. Now they have the variable a, and for every single trig function, it has a different effect. So for secant and cosecant, the effect of amplitude just creates that gap in the range, and that's really all it does. So just want to make that clear, because I feel like I made a mistake and did you all disservice. Right. Amplitude is distant from midline. You are correct. And only sine and cosine actually have an amplitude. And it has to be, so another piece of that, it has to have a max or a min. And yes, cosecant and secant do create maxes and mins, but not in the typical sense of a sine or cosine wave. It's more like kind of flips outwards. Yeah, there's a definition somewhere in the notes about it. They do, but it's not the typical amplitude. So here you go. Okay, let's get started. So I emailed everyone the review yesterday, correct? Was it yesterday or day before? I forget. Okay, and hopefully all of you had a chance to work through them all. You had the answer key, because we're kind of going to zip through this. You have 30 questions on your midterm. All right, we're being recorded, of course. All right, so first one. You got to evaluate each arithmetic series described. All right, it's arithmetic, and this problem wants, when it says evaluate, it wants you to find the sum. That's what it's implying. It wasn't necessarily clear, and maybe you figured it out because it's A, B, C, or D. So evaluate just means what's the sum of the arithmetic series described. So you just use the summation formula. Yeah, plug and chug, and that's how you get the answer. Pretty good, right? All right. Next one, we want to evaluate each series. So this is kind of straightforward. This is the summation. So from k equals 1 to 5, so all you're going to do is write this from 1 to 5, 1, 2, 3, 4, 5, starting at 1, ending at 5. That's what this means, start and end. So if k was like 3, k equals 3 to 5, we would start at 3 and go 3, 4, and 5. This doesn't represent how many terms you need. It just that is the stopping point, and this is the starting point. So 1 to 5 in this case. So you just write it, and you can just plug and chug, really.
Can you go back to question 1 really? Thank you.
At the very end, I'll provide a link for all of you that are here. All right, number 3. All right, so this wants you to find the fourth term in the expansion. All right, so I like using Pascal's triangle, and we're using this line here. This number represents this as a kind of a shortcut instead of counting. So we're using 1, 5, 10, 10, 5, and 1 for the coefficients. So I like writing those out: 1, 5, 10, 10, 5, and 1. And then I like just putting parentheses representing where, well, these terms would actually go for all of them. And then we care about the fourth term. So maybe above. So this would be the first term. This would be the second term, third term, and then this is fourth term. So maybe above this, I would put kind of like a line or a happy face to show, hey, this is the one that I want. And then, so I would, rather than set the entire thing up, I would just count over to the fourth one, and then I would put 2a here. I would put whatever this is, negative b cubed here. And then for the outside exponents, we just count down from the first one, 5, 4, 3, 2. So 2 goes here. And then for the second one, we start on this side and go counting down 5, 4, and then 3. So that way I only set up less than half of the entire expansion, because we only care about the fourth term of this expansion. So then we just do the math. We got 2 squared is 4. A squared is a squared. Negative 1 cubed is still negative 1. b cubed to the third power is b to the ninth. And then I would just do 10 times 4 times -1 is -40. A squared times b to the ninth is, well, a squared b to the ninth. And we're done. Pretty straightforward.
Do we need the 1 in front of the b?
The 1 in front of the b. What is 10 times 4 times -1?
It's -40.
It is.
Oh, okay,
yeah.
okay, I got you now.
Yeah, so having a 1 there, it's not simplified because you're saying -40a squared times 1b to the ninth. So you have, and the -40 times 1 would just be -40, just to kind of clear or expand on your on the answer here. Okay. All right, number 4 here. It says rewrite each series using sigma notation. So the nice thing about multiple choice questions is you can pretty much just guess and check. And if you went through all of these, and we remember this is n equals 1, n equals 2, n equals 3, 4, and 5. So for example, rather than check the first one, just jump to something further in the series, because there's a good chance that the first term actually might work for more than one of these answers. I don't know if they do. I didn't check them. But usually, if you kind of go down and pick something further down the line, each series will be very different, and the odds of actually getting them to be the same number for n equals 4 here, pretty slim usually. So I would plug in n equals 4 to see if I get 2 here. Well, 8 divided by 4, well, that's 2. If I plug in 4 here, well, that's 4, and I actually wanted 2, so that doesn't work. 2 to the 4th power is definitely not 2. And then 4 times 4 is 16, and we wanted 2. So, that's a quick way to check just one of those. I wouldn't check the first one. Would not check the first one. Hopefully that helps. And then I think actually this is right here is just showing the work of why it works. So doing that for every single term in this sequence here gives me these numbers here after you reduce. All right, number 5 here. Find the term named in the problem. So we want to find a sub 10. So I don't tell you if it's arithmetic or geometric. So you need to figure that out first. So -1 to -1/2 to -1/4 to -1/8. Well, to me, it's pretty clear you're multiplying by a half every single time. So that's your common ratio is a half. And remember, a way we can do that is we take this number divided by the previous number, this number again divided by the previous, this number divided by the previous will give you r equals 1/2. So that's how you find it mathematically if you can't see it right away. And because we're finding the 10th term, you want to look in your notes for the equation, or the formula for the arithmetic specific term. I think I somehow labeled it or along those lines, or a particular arithmetic term. That probably sounds closer to what I labeled it as. And we just plug the stuff in. We plug in your first term, you plug in your common ratio, and you plug in what term you want, and we just do the math. And that's how we get this answer here. And looking at this pattern, you know what? This is why I don't like multiple choice tests that are generated. Because when a computer generates answers for questions, it doesn't necessarily make other answers with common mistakes in them, right? So it's pretty clear that the numerator is always going to be 1. So you can kind of eliminate all 3 of these answers without even doing any work. That's unfortunate. So And honestly, I don't have the time to work out 30 problems and 30 or 4 solutions for each. And I would make it really good. So common mistakes would get you some of those answers. Anyway, I digress.
Wait, so are these the exact ones from the test?
No, of course not. That'd be foolish of me.
You made one like that?
I'm sorry?
You made one like that then?
No, I used software to generate questions.
Oh, okay. I was like, I never expected you to do that to us, but okay.
No, I use software to generate these. It would take me way too long. Each problem would take me probably at least 10 to 15 minutes to work out, to create. It's a lot of work to create good wrong answers. All right, number 3, determine if each sequence converges or diverges. Well, this is nice because it's only A or B. So you need to check your notes of the definition of what it means to be convergent and divergent. So for at least for this one, we can see it goes 3, 9, 27, 81, 243. Well, it gets bigger, bigger, bigger. So it definitely doesn't converge onto a single number. It's definitely going to infinity. So that would be considered divergent. So check your notes. I gave you the day. And look up what it means to be convergent, because there are situations, whether it's arithmetic or geometric, and how to be convergent. So do that. All right, number 7, evaluate each infinite geometric series described. So again, evaluate means to find a sum, and it's geometric, and it's infinite. So in your notes somewhere, you have a formula for the summation of an infinite geometric series. You also have a equation for the summation of a finite geometric series. So make sure you use the right one. In this case, we're doing infinite, and then that is the formula. And we just plug the stuff in. A sub 1 is, well, -3. So I plug that in here. The common ratio, we find that by doing -3/2 divided by the previous. And I show that work here. And we just plug everything in, and we just hit enter, and we get -6. All right, number 8. Find the missing terms. So this one you can kind of guess and check. Just see if the pattern kind of makes sense. See, this is why this is a bad problem too, or bad choices. So it goes 5, and then it goes 6, 12, 24, and then 31, 25. That just sounds really weird. And then the numerator is always 5, 5, and 5. That doesn't make sense. So just pattern-wise, it just doesn't strike me as, well, a pattern for A. So I think A is a really bad choice. Going 2, 6, 18, then 162, 5, 25, 125, and 31. Yeah, see, this strikes me as a very bad pattern too. That would fit this just by observation. Let's see, this one seems a little better. So 2, 8, 32, 128, 162. The bottom we got 5, 15, 75, 375, and then so I think D would be a better distraction, which is it's still a wrong choice, but I think D would be something people might choose over B. But definitely A and C are really bad choices, just by observation. But anyway, mathematically, what we can do is actually figure out the common ratio. So we use the geometric A sub n formula. We plug A sub 1 is 2 over 5, so I have that here. And then A sub 5 is, well, this number here. So we plug, we're doing, instead of n equals 1, which is here, we're going to make A sub 5 this value right here. So that's why I have A sub, I'm sorry, not A sub 5 here. A sub 5 is here. A sub 1 is this value here. N is 5. You just plug it all in, do the math, and we find a common ratio. So we'll use the first. I'm sorry, we're not using the first. I guess technically this is the first and the fifth. So whenever you see a sequence, we didn't cover this in class actually. When you're given a sequence and you are not given the first one, you're giving, in this case, ... So this could be the 10th, it could be the 20th, it could be the 100th, it could be the 1000th. When you're given something like this, you don't know anything before that, it doesn't matter. What you're going to do is treat this first one as your first term in the sequence. So this is a sub 1, 2, 3, 4, 5. Anything before that, we just count backwards, and that will still hold true in the equation. So this will be, it'll be a sub 0, and then a sub -1, and a sub -2. We didn't do any of those in class, but if you take this course in college, you may run into something like that, maybe. Just want to point that out. The more you know, right? Take that answer. All right. So once you know 3/5 is the ratio, you just multiply by 3/5. 2/5 times 3/5 is 6/25. 6/25 times 3/5 is, well, that fraction times 3/5 is that fraction times that fraction is that fraction. So it's a good way to check. All right. Long explanation. Sorry. All right. Number 9. Find the reference angle. Well, I drew. So draw a picture. I think you always want to draw pictures when you can. So reference angle, remember, reference angles are angles that are made between the x-axis and the terminal ray. So I drew a picture to show that. We are in quadrant 2. So theta is the given angle. Reference angle is the angle made with, well, the closest, well, x-axis, which would be the negative x-axis. So, you probably want to check your notes of, I gave you 4 equations of actually how to calculate alpha here, which is the reference angle. So visually, it's going to be 180 minus theta. Or if you're given the angle in radians, it's going to be, well, a half rotation is just pi, so it's going to be pi minus 5 pi over 9, and that gives you 4 pi over 9. So I showed you both ways to do it. Convert it to a degree. Didn't do it that way, then convert it back to radians, or just just deal with it in radians. It's up to you. Okay, find the exact value of each trigono. Okay, so it looks like my unit circle cut off the directions. So it's something, whatever I sent you in the email yesterday. So we want to find the exact value of this. So the sine of negative 5 pi over 6, well, 5 pi over 6 is, where's 5 pi over? There's 5 pi over 6, but it's negative. So rather than go 150 degrees this direction, we're going 150 degrees the other direction because it's negative. So we're actually talking about this right here. And remember, sine, what variable is sine? Sine is the y, yes. And it is extremely important that all of you know by now, sine is y, cosine is x, tangent is y over x. You need to know that top of your head. We're going to use it next unit for sure. All right, so going back to this, sine is y, so the y value is negative radical 3, I'm sorry, 5 pi over 6. Oh, sorry, we're at this angle. I pointed the wrong one. Y is negative 1/2, so that's why the answer is that. You also might be able to type in the sine of negative 5 pi over 6 and hit enter, and you should get the same answer, negative 1/2. You, of course, want to be in radian mode because that's what it's giving you, radian mode. Remember, so you may have to jump back between radian and degrees back and forth. Just make sure that you are in the right mode for the problem you're working on. So in this case, it's obviously radians. but I like using circles. They're cool. All right, another problem, just like the last one, cosine of negative 5 pi over 4. So negative 5 pi over 4. So 5 pi over 4, well, that's right here, 225. So rather than going positive 225, we are going negative 125 or 225. So we're actually going to be right here. And that's how we get negative radical 2 over 2, the x value, right there. Number 12. All right, find the exact value. So tangent, remember, is y over x. So 7 pi over 6. Well, let's look at 7 pi over 6, which is right here, 7 pi over 6. Remember, tangent is y over x, so you just take the y value, which is negative 1/2, and divide it by negative radical 3 over 2. And that's what I did right here. There's my setup. We flip and multiply. Oh yeah, and a negative divided by a negative is positive, so that's why in this step I don't have the negatives in there anymore. I just did that real quick. And then we just rationalize here, and that's how we get this answer there. One thing I wanted to point out, I think all of you should have this printed out somehow. But one thing that if I was in your shoes, still a student, I would probably write the tangent. So at this angle here, actually for all these angles, I would put the tangent of this is equal to whatever it equals. Because if you notice, a lot of problems, they talk about tangent, inverse tan of these angles, and we have to do almost the same work every single time to just to make sure what it is. And if you have on your unit circle what the tangent of all of these angles, at least maybe just these first three, because it's just a mirror of these, right? Just makes it whether negative or positive. If you do the tangent of these three angles, or these three angles, you'll have them right in front of you, and you never have to do that again. You just look at your unit circle. Does anybody already do that? No? Okay. Jeez. No one's talking in chat. I'm going to stop holding live sessions. Good luck. Just kidding. Just kidding. All right. Kind of. Number 13. In each triangle, ABC, angle C is a right angle. When find the value of the trig function indicated. So draw a picture. It does say C is the right angle, so that's why I put C here. A and B doesn't matter which is which. But when you label this, just like in diagrams, if this is angle B, remember capital letter B, the opposite side is lowercase b. So if this is angle A, the opposite side is lowercase a. And then there's capital C angle, opposite side is lowercase c. It matters. So if you didn't pick that up, this unit or in geometry, I'm stating it. I'm stating the obvious. All right, so we create our triangle. That's the right angle, and then it says so we want to find the tangent of angle A. So we want to find the tangent of angle A if side A is 6 and side C is 10. So I put 6 and 10. I would also suggest maybe circling the angle we're talking about. Because tangent, so I saw this on your TGA last unit. Some people, they would write tangent or whatever it was, but then they wouldn't do opposite over adjacent correctly. I don't know if they were I don't know what their thought process was. But, so this right here is your opposite, and then this side right here, that's your adjacent, and then this, of course, is your hypotenuse. So adjacent means next to. So labeling stuff, I think, it really goes a long way. All right, so then we just let's see. So tangent is tangent of A is opposite over adjacent, and before you find adjacent, you obviously have to do the quadratic, or not quadratic, the Pythagorean theorem, which I did here, and then we'll have a B being 8. So opposite is 6, adjacent is 8. Reduce it. There you go, 3/4. Tangent of A is 3/4. So what's adjacent to B? All right, so good question. Let me use different colors. So if I was, so that's why we circle, whoops, I'm not using my pen. That's why we circle the angle you're working with. So it kind of visualize we're standing on angle B. So now opposite, opposite, and then this one would be adjacent. So that's why it matters what angle your point of reference is. Does that help?
Okay. So then if we were here at C, then adjacent would be B.
Well, so remember, C is a right angle. So B and A are actually adjacent to the right angle C. But you would never ever do that because it's a right angle. There's no reason to do that because angle C is 90 degrees. There's to be no purpose to even using angle C as a point of reference. Are your minds blown right now of this concept? Okay. Not really. All right. Well, that's good because we did geometry a long time ago. But if your mind is open to like, wow, I didn't know that. Well, now you do. So it all really kind of matters how things are presented to you guys, right? And how you learn it. So if you weren't presented in a meaningful way to you, it didn't make sense. All right, so converge each degree measure into radians. Well, I didn't do this work because this is obviously really easy. You just multiply by 180 over pi. Remember, that's the conversion. And without even looking it up, we know it's 180 over pi because, well, this way the pi's will cancel out. And then you have 5 times 180 divided by 9. And then that's how we get 100. So easy way to tell is the pi should cancel out. All right, yeah, same thing. So we want to convert into degrees. So again, multiply 180 over pi, and these obviously cancel out like they're supposed to. And then, yeah, you type that in, and you get 625. Pretty simple. All right, converting this into radians, well, we multiply this one by, well, pi over 180. And without looking it up, we know it's pi on top because, well, we want our answer to be, well, radians, and pi is in the numerator for radians, usually almost always. And that's how we get 7 pi over 4. This one here, again, this is multiply again by pi over 180. So yeah, just type that in and you get your answer. Yeah, that's 4 questions on your test. That's, in my opinion, that's 4 freebies. Why did I do that? Why is this test going to be so easy? All right, let's see. Use the given points on the terminal side of the angle theta to find the value of the trig function indicated. So we want secant of theta, and the coordinate is radical 5 comma 2. Now, it doesn't matter if you graph that point accurately or not. It really doesn't matter. What matters is x is positive and y is positive. So because x is positive, y is positive, you know right away we're in quadrant 1, right? Everyone should be able to look at these coordinates and determine if you're going to be in quadrant 1, 2, 3, or 4. So because they're both positive, I just drew some doesn't matter. I just drew a line in this quadrant. The x value is radical 5. The y value is 2. And we want the secant. And so secant is the inverse of cosine. And using SOHCAHTOA, cosine is adjacent over hypotenuse. So secant is just, well, flipped. Hypotenuse over adjacent. So you need to know that. You need to know at this point, top of your head, that cosine and secant are inverses. Sine, cosecant are inverses. Tangent, cotangent are inverses. So at this point, you should know those. And if you don't, write it down and study it. And because we drew this picture here, your point of reference is this angle. So hypotenuse is this long side. For a circle, it'd be called the radius, right? And so we have to use, well, the Pythagorean theorem. Remember, a squared plus b squared equals c squared. So I just did it right here. Square roots of 2 squared plus radical 5 squared. Type this in, I get 3. So I didn't do a whole lot of steps here. All of you should be able to do the Pythagorean theorem and understand how I got to this step. If you don't, you need to write it out to see how I got to that step. I'm not going to go over it any further than that. All right. Anyway, so 3 is the hypotenuse. And if you want to label these, this is opposite of this angle. This is adjacent to this angle. And this is, of course, the hypotenuse. Label it so you don't make a mistake when you actually take these numbers and, well, plug it into h and a. So h is 3. We found that. And then adjacent is radical 5. Don't forget, we got to rationalize it. And that's how we get this over here. Pretty fun. So draw a picture. It'll help a lot. All right, 19. Let's see. All right, in each problem, angle C is a right angle. That's nice. Find the side indicated to nearest 10th. All right, 10th. So that's 1 decimal place. All right, angle C. So C is the right angle. So again, angle C, I just, oops. Oh, it didn't matter. I left out angle A because we're not actually using it. I'm gonna go ahead and write it in though, because I think some of you are probably freaking out right now. You can't see it. So this is angle A, and this would be side A. I'm just doing that for completeness. All right, so our point of reference is, let's see, find side C if side B is 3 and the measure of angle B is 65. So we have to label our triangle. So side C is here. We're trying to find that one. B is here, so I called it 3. And then angle B is here, and that's 65. So yeah, you want to set up your triangle for sure. And then we're trying to find side C here. So I think this is one possible way we can do it. It might be more than just this choice. This is probably the easiest. I could have used something else actually. This is one of a few ways I can see how to do this problem. So the sine of 65, sine is opposite over hypotenuse. So that's why it's sine 65 equals 3 divided by c. We switch c and sine 65 as a little quick trick. And then we just type this in, 3 divided by sine 65. And again, we are in degree mode now. So make sure you put in degree mode, because we were in radian mode from previous problems. 3 over sine 65, hit enter, you'll get 3.31. Also, another a good thing about multiple choice problems, if you forget to put it in degree mode and you type this in, you hit enter, your answer won't match anything up here, more than likely. And you're like, oh, well, that's why, degree mode, whoops. Almost done. Find the min and max values. So y equals sine of theta. So you want to graph this in probably GeoGebra, but remember, this is our last unit here, and this creates a sine wave. Min and max, those are the amplitudes from the midline. So if you know your midline, there's no shift, it's just y equals 0. To find the max, it would be the midline plus your amplitude for the max value, and midline minus the amplitude for the min value. And well, there you go. Or you can just graph it. If you just graph it, you can see the max and the min right on the graph on GeoGebra. So 1 and -1. I think that's a freebie as well. There's not a lot I wouldn't do, guys. Math-wise, watch out. Oh, yeah. For every freebie, there's an impossible question, right? All right, find the amplitude. Well, that's super easy. It's just the number in front, 3. Another freebie. This test is too easy. You know what? I really wish one of the choices said -3. I really wish it did. Sigh. Another freebie, because we all know that this number is your vertical shift. So this would be, look at this. There's no negative in the shifting. That's a jab at the people who did that. Look, this tells you it's down, so the answer is down 2. Whew. Oh boy, that's amazing. This is a freebie for, I think, most people. Again, I kind of wish it said, I wish it was A, B, C, D, E, F, G, H, and they would have the direction, but then they also have just like plus and minus signs. I think that would be just great. It would make me smile. And honestly, I could do that, but it's too late for me to add that into the test. It's too late. Find the period in radians. So remember, sine the parent function, the period is 2 pi. So to find the period of this, we're doing p equals 2 pi over k. Your k value is 8. So we plug that in, we do the math, and that's how we get the period is pi over 4. Oh, speaking of that, I feel like people aren't going to see this. The ones that need to see it. If I had, let's say, y equals, let's think. Let's say 2 sine of x. All right, chat. What's the amplitude? 2. Yep. Yeah, so that's pretty easy. And then what's the k value? It is 1. Yeah. So the people that need to see this problem are actually not in the live session right now. On TGA, many people put the k value being 0, and no, that's completely wrong. Because if it was 0, it would say 0x in parentheses after the sign. Because there's a coefficient. If it's invisible, there's no number here. It's always a 1. We learned that in pre-algebra. So on your TGA, again, adding to my math panic attack yesterday, I kept seeing a lot of k equals zeros in something like this. I was like, oh, come on, killing me. All right, 24. Find the period. So again, cosine, the period of parent function is 2 pi. So and the k value is 2. And we just, well, in a way, I feel like this is like a really easy question as well, as long as you know the formula, right? If that was a tangent right here, what would you have on top here in the numerator? Pi. Pi is correct. $25. I got to hurry up. It's 11 o'clock. You're welcome. All right, find the exact value of this. So inverse sine. So this is asking you, what is the angle given the y value is this, radical 2 over 2? Well, so we come over here, the y value, remember sine is y, so radical 2 over 2. So there's radical 2 over 2. So the answer is pi over 4. So there's actually 2 answers. The other answer would be this right here, 3 pi over 4. But your multiple choice is actually only going to have one of the answers, and it's probably going to be the first that occurs in your rotation. So that's why it's pi over 4. Now, a good multiple choice test, I think, I would have omitted pi over 4, and I would have had 3 pi over 4 instead, and then I would have had something else for here. And then typing this in wouldn't have yielded any of the answers, and you'd be forced to use the unit circle to identify that the answer is also 3 pi over 4. But it's sine. It's inverse sine. Yes, and this is not -1 time. This is arc sine. This is the arc sine of radical 2 over 2. So remember, when you're doing arc sine, in arc sine, you're given the coordinate and finding the radian. If you're doing just sine, you're given the radian and you're finding the coordinate. No, it can be 3 pi over 4. No, both answers are correct. Both answers are correct, but for the review and the test, you're only going to have one of them listed. In this case, I list pi over 4. True, but the problem doesn't state a domain restriction. Does that make sense? Remember, the domain restriction is pre-programmed in your calculators. That's why it wouldn't give you the other answer. Yes, inverse functions do need a domain restriction to give only one solution. Now, I could have made the domain restriction from pi over 2 to 3 pi over 2, and then you'd be forced to find some answer over here. And then your calculator would be no good. Remember, the domain restriction is only there for you to actually graph a function, if that makes sense. Remember, functions must pass the vertical and horizontal line test. So I'm going in far too depth. But anyway. All right, same thing here. We're doing the inverse tan of radical 3 over 3. Well, so this is positive. Remember, tangent is y over x. So you are finding the quadrant where y divided by x is positive, and that occurs in quadrant 1 and in quadrant 3. So looks like the answer is pi over 6. And to test that, we do 1/2 divided by radical 2 over 2, which I show here. We do the math, and you get radical 3 over 3. This would also work at the angle 5 pi over 4. You would get the exact same answer. But because of the pre-programmed domain restriction, and this has the assumption that it's only from 0 to pi, that's why the answer is just pi over 6. (27) Inverse cosine of the sine of negative pi over 6. So some calculators, you are forced to do a piece at a time. So you would type in the middle piece first. So the sine of negative pi over 6, I did over here. And I get negative 1/2. You can also use the inverse, the unit circle, and you're going clockwise pi over 6, and you would find the y value to be, well, negative 1/2. Typing this in will also yield the same number here. And then I replace what we found with 1/2. And then I do the inverse cosine of that value. Again, radians we're dealing with here, this problem. And the answer is 2 pi over 3. And just showing you there is actually 2 answers if you do it by hand using the unit circle, but only the first one really matters for this. All right, this one's super easy. This one has a vertical shift of up 1. That's going down. That's going down. That is definitely either cotangent or tangent, so it can't be that one. This one actually only has a vertical shift of up 1. So this is really the only choice without actually typing this into GeoGebra that makes sense. That's the only one that has a vertical shift going up 1. Yeah, womp womp. Easy. All right. Y equals 2 cosine theta. So the amplitude is 2. No shifting. Looks like all of these, looks like they all do not shift, which is good. Amplitude, so this is amplitude of 1, amplitude of 2, amplitude of 1, amplitude of 1. So based on the amplitude, you can narrow down it to just choice B. Last one. All right. Find the transformation. Pretty simple. So the vertical shift is definitely down 5. So I would start there and look at what choices don't have down 5 and cross them off. So this one says up 5, so we cross out B. That's a bad choice. This is down 4. That's not enough, so B and D are gone. So it really comes down to choice A and C. So this one says horizontal shrink by half. This one says vertical stretch by 2. Well, only amplitudes can cause a vertical stretch or shrink. So just because of just this doesn't fit, there isn't an amplitude, we can cross out C. So without doing any math, the answer is A. Pretty simple tests for the most part, I think. And hey, the password is halfway there. Case sensitive. I think answer D was having answer D. Yeah, I agree. Wires are not connected correctly. Yep. So halfway there. All right, so get your midterm finished. So all of you should have your Unit 3 test Part 1 done, Unit 3 test Part 2 done, your midterm test done, and we are starting Unit 4 tomorrow, and Unit 4 is long. Like it's 4, maybe 4.5 weeks long. It is long. Like a month. Yep. Yep. Rip my brain too. Well, guys, thanks for coming. See you tomorrow.